Ever wonder how scientists turn blurry, noisy telescope images into stunning, detailed views of distant galaxies? It's not just magic, it's cutting-edge AI. Today, we're diving into a fascinating study that uses deep learning to translate galaxy images, turning low-quality data into high-resolution treasures. Let's break down how this works and why it's a game-changer for astronomy. So what's a galaxy image translation model? Think of it like a supercharged photo editor. These models take blurry or incomplete images of galaxies and generate sharper, more detailed versions. But here's the twist. Researchers tested two approaches. The first used original telescope data to train the AI, while the second used already generated images. Why? To see which method produces more accurate results, and how AI learns from its own creations. The secret sauce: neural networks, computer systems inspired by the brain. The study compared several architectures, like the Swin Transformer, SRGAN, capsule networks, and diffusion models. Each has its own superpower. For example, the Swin Transformer breaks images into tiny pieces, analyzes them, and rebuilds them with stunning clarity. SRGAN, on the other hand, acts like a digital artist, refining details to make images look more realistic. Imagine you're trying to paint a portrait from a grainy photo. The Swin Transformer would first identify key features, like the eyes or nose, then carefully reconstruct them. SRGAN would add texture, making the skin look smoother or the background more vivid. And diffusion models. They're like digital time machines, learning to undo noise step by step, just like removing blur from a photo. The results: the models trained on original data outperformed those using generated images, proving that real-world data still beats AI-generated outputs. But here's the kicker. Even when models made mistakes, like misjudging a galaxy's G-R color, a measure of its brightness in different wavelengths, they often did so in predictable ways. This means astronomers can learn from these errors, using them to refine future models. Think of this process like teaching a child to recognize animals. If you show them real photos, they'll learn the true diversity of shapes and textures. But if you only show them drawings, they might misidentify a zebra as a horse. Similarly, AI trained on real telescope data preserves the subtle cosmic clues, like redshift, that define a galaxy's true nature. Now let's get technical. Redshift is the key. It's the stretching of light waves from galaxies moving away from us, acting as a cosmic odometer. But when AI translates images between telescopes, it's not just reshaping pixels, it's navigating a complex web of astrophysical data. For instance, the Swin Transformer excelled at maintaining galaxy morphology, but even it struggled with preserving the precise redshift signatures. Why? Because translating between surveys like SDSS and CFHTLS requires mapping not just visual features, but the underlying physics of light emission and detector characteristics. Here's where it gets wild. The study found that AI models trained on synthetic data introduced systematic biases. For example, SRGAN and diffusion models added noise or distorted color gradients, which could mislead redshift calculations. Meanwhile, capsule networks simplified structures too much, losing critical details in galaxy arms or halos. The Swin Transformer, while the most robust, still couldn't fully replicate the nuanced spectral features that astronomers rely on. So what does this mean for the future of astronomy? It means AI is a powerful tool, but not a magic wand. These models can accelerate data analysis, but they require careful validation. The takeaway: never trust a pixel without a physics check. As telescopes like the James Webb Space Telescope push the boundaries of discovery, AI will be our ally, but only if we teach it the right lessons. Next time you see a stunning galaxy image, remember, it might be the product of human ingenuity and a little bit of AI wizardry. Thanks for watching, stay curious and keep exploring the universe.